In this video we are going to do the review of this WUZHI WZ10020 which is 1000 watt MPPT step down converter and battery charger. Going to test all input and output voltages from 100 volts, 110 volts input, and then output 100 up to 3.3 volts, and also we will change it to 70 volts, 50 volts, 36 volts, 24 volts, and we will test it with different voltages for 19 volts as well. We will see the current, we will see the ripple, we will see the efficiency, the output input power, so you can calculate and see the efficiency, and we are also going to show you how to charge a battery as well. In this video we are going to do the review of this WUZHI WZ10020L 100 volts 20 ampere or 1000 watt step down converter. This is a detailed video. On the larger screen you can click here on the status bar and you will see different chapters of the video. On your mobile device you will see the menu. When you touch it you will see all the chapters where you can click and touch to move to that section of the video. This WUZHI WZ10020 which has input of 110 volts and output 100 volts from 0 to 100 volts and from 0 to 20 ampere and 10 ampere. It has a separate display that you can connect it to a panel or something, and it has separate battery feature that you can control, and it has MPPT for solar, so the voltage, the input voltage can fluctuate high and low, and it will give you a fixed value, and there is a relay that protects it. It will not allow the current to come back if you connect your battery in here, or you can also get the output as constant current and constant voltage for any other purpose that you want. In this presentation, first module will be explained. We'll view components under the magnifier, then the settings will be explained, and then we have the demo input output voltage. We try to check the display current and voltage accuracy, and then I'm going to show you how to charge lithium iron phosphate battery. We will do MPPT solar test and see how it works. Then we will have a look at the ripple voltage, the output ripple voltage, and switching frequency. So the main feature is that it has constant voltage, constant current, it has an LED display. So input voltage is 10 to 110 volts, output voltage from 10 millivolts to 100 volts. With the current also can be set up to 20 ampere between 0 to 50 volts, and the current is 0 to 10 ampere when the voltage is between 50 to 100 volts. The total output power is 1000 watt, and input voltage accuracy that it shows is 1% plus 5, and then output voltage is 0.3% plus 5 plus minus 0.3%, and then the capacity measurement is up to 99.99, that's 1000 ampere hour, and the time measurement capacity is, the time measurement range is up to 100 hours, you can set it. Output ripple is 300 millivolts. Operating temperature, they mentioned it as minus 20 to 50 degrees Celsius. And it has a protection of over voltage protection, over current protection, under voltage protection or low voltage protection, over capacity protection. So you can set a capacity of the battery. When it is drained or that amount of capacity reached, it will stop. And then timeout protection. Then the test that we do is, first we will have input of 110 volts, and we do all these output voltages. Then we check and then we set the input voltage to 90 volts and we test all these voltages. Then we set the voltage at 70 and we test all these voltages with different current. Input will be 50 and then we test all these voltages. Then we change it to 36 volt with all these voltages, 24 volts with all these voltages, 19 volts with these voltages, and then the last would be 12 volts with these voltages. Please don't forget to subscribe by clicking on this icon now. Thank you. I tested this, and the current, the output current that shows is incorrect. So during the test, please ignore this, as we will see the actual current somewhere else. And I believe this is the module. I've requested them to see if they can fix, or they send me another one. But regardless, the rest of the features are working very well beforehand. So we will do the test and see it. And here on AliExpress, it's sold with different prices. This guy has added the shipping, so $35.21, and you might find it cheaper or more expensive depending on the option and how fast you want to receive it. I'll provide you the link so you can purchase it. Here is the package. I received it like this. So we have the display and the module, nothing else. The manual can be obtained from here if we scan it with our phone and visit the page. Let me explain the module input and outputs. We have here two terminals for the battery. It says battery minus, battery plus, and we have out. This is for the output, and here this is for the input. So this could be connected to the solar panel or a charger or whatever you have, and this way we have a battery and the input. And here we have on off switch, a tiny on off switch. This is the fan. We have two power MOSFETs, and this is the display. We have about 16 centimeter or 6 inch the length of the cable. We have a rotary encoder. When I rotate it, I feel that. So it says voltage and current, and switch on constant current, constant voltage. So this is on, constant current, and we have on off. When I press it, it will be turned on and off, which I'm going to demonstrate and show you. On the module, for the protection, there is a 30 ampere relay. This is a very powerful relay. And then we have microcontroller. This is a boost converter, which I'm going to look under the magnifying glass. Now let's have a look at the components under the magnifier. I used an Star digital magnifier for this. The link to purchase this is below the video in the description. Let's have a look at this chip here. And this is the H6203L. Here is the data sheet for H6203. This is a pulse width modulation chip, which I cannot read. Let's have a look at this chip, HT9901. Let's have a look at this chip. This is LM358. That's an operational amplifier. Here is a data sheet for LM358. This is a single supply operational amplifier. Let's have a look at the microcontroller, this large chip. And as you can see, it's MM32S pen. And here is a data sheet for MM32S pen. This is a 32-bit microcontroller based on ARM Cortex M0. Let's have a look at this chip. This is also LM358 single supply op amp. This is the relay, 30 ampere. So that's the rated current for this. You can see here we have two 20 ampere fuses. Two 20 ampere fuses here. And here we have one more fuse in here. Let's have a look. And here, that is a 20 ampere fuse for the input. The 3 shunt resistors that all current passes through them. Let's have a look at these 2 power MOSFETs or power chips. First one here is NCE P15T14. Here is a data sheet for NCE P15T14. This is super touch. This is in-channel super trench power MOSFET with maximum current of 140 ampere at 150 volts drain source voltage, and RDS, when the drain source is turned on, the resistance is less than 6.2 milliohm. And as you can see, this is also NCA P15T14. Let's have a look at this chip, the 3-pin. Perhaps it's a regulator or diode. Let's see. So this is MBR 30150. MBR 30150. Here's the data sheet for MBR 30150. This is a Schottky barrier rectifier. So inside the package we have 2 diodes, 2 Schottky diodes, each 15 ampere. So if you use them in parallel, then we can have a 30 ampere current Schottky. So it says 15 ampere per leg and 30 total. Let's have a look at this small chip which is connected to this inductor. Perhaps that's a converter, and that is B6280. B6280T. This is a step down converter, 6-pin with this amount of current. This is 1.7 to 5.5 volts, 0.6 ampere or 1 ampere step down converter. We have a Schottky diode here, and I believe it's connected with this fuse for reverse polarity protection. It will be used as well. Let's check it. And here I put it on diode test. Let's go positive on this side, negative on the other side. As you can see, that's 0.3 volts diode. If I go on the other side of fuse, yes, so this diode is connected like that, and this is, let me check it, and let me check if it is connected. The anode is connected to the negative terminal, correct, and the cathode is connected to the fuse and to this. Correct. So this is a reverse polarity protection mechanism. When you connect it incorrectly, the fuse will blow. The fuse will blow up. If you're interested to purchase this, I will provide you the affiliated link below the video. It will help me if you purchase it through that link. Thank you. Now let me explain the settings. We have the switch here. We have UI, voltage, current, that means voltage and current, and then we have rotary encoder with these 2 buttons. By default on the screen you will see the output voltage and then some value here. Now the output is not on. If I press this push button, the output will turn on, and that is the set voltage for the output. I hope it's now better. If I press this button, it changes to ampere, that it shows the output current, and if I press this again, it shows the output power. Press it again, it shows the output capacity from the time you did not reset it or from start time. If I press it again, it shows the time in hour, this many hour and minute, so this is 19 minutes, and if I press it again, it comes back to current. Now to see the input voltage, press and hold this for more than 2 seconds, and this is now input voltage, 110 volts DC is coming to the input of this. And if I press this again at this stage, the top will not change, it just changes the unit. Again, watt, ampere hour, hour, and then current. So to exit back, you have to press it again. It shows now, I pressed it for more than 2 seconds, it shows now the temperature, and if I press it again, it goes back to the output voltage. So we got that. Now let's see how we can set the voltage. Press this button and the voltage will blink. Now if I want 80.5 volts, I just rotate it, that's 80.5. If I want to go to 81 or something, just press it, and here I can go 30 volts, for example, 30.5, and if I press it again, it comes here, and I can set it so 30 volts. Either at this stage we can press this for 10 seconds and it will exit, or press it for longer time, it will exit, or wait for 10 seconds, it will be set. So now the voltage is set, but let's see what is the current. So to set the current, we press it, this is voltage, and you see the set here. Now if I press it again, the current is now blinking. I can go and set it, let's say to 17 ampere, and wait for 10 seconds and it will exit. So it is exited, but the current is set. Now let's talk about the protections that this module offers. So first, press that I/O button for more than a few seconds, and then using the, when you see open, off, or on, whatever is set, press SW. You will see that this is low voltage protection. So that's the low voltage. If the voltage is set below this, it will not allow it. If I go again, it's over voltage protection, so you cannot set more than this value. Over current protection, 20.1 for example. Over power protection, 1010 watts. And this is over temperature. This, yeah, just read this as T, over temperature protection, and you can set it like that with, and then over capacity, over, what is this, OAP, over capacity, that's over capacity protection. This is over time protection or timeout off, how long you want, after how long you want the device to be turned off. Here are the values, or the screen value, the interface that you see. If you see open on, this is the normally open, open off, normally closed. And then under voltage protection, this LUV, this is OVP, over voltage, this is over current, and then OPP, over power, and then we have over temperature, OTP, and then over capacity, and this is over capacity off or on, and then amount of the capacity, and this is over hour protection, over time, that's for time off or on. And then once you set that, then we have the time for that. So after how many hours you want it to be turned off, and this is the zero current, when you can set it. This is the mode setting. When you set this option, if I press open off, let's set it to on. Just press this and hold it for a few seconds. It is on. Now to exit, press this I/O, hold it. We have exited, and now this is on. I'm disconnecting it from power. So it turns off, and now if I connect it, you see it turned on automatically. Now let's turn it off and see if it has any effect. Now output is off. I'm disconnecting it. It takes a long time before the voltage drops because there are big capacitors. And now let me turn it on. Now again, so the output will be on automatically because we set it. If you don't want that option, hold this back and hold this again, set it to off and click save to exit. Here is a demonstration of constant current. If I press this briefly, you will see that I've set the output current to 6 ampere and I'm setting the current to be 10 ampere constant current. So here the red light is turning on. It's showing that constant current is active now. If I turn this off, it will turn off. So now the output is 48 volts, input is 50 volts. We are getting 46 volts, so the voltage dropped because the input and output are very close. Now let me increase the input voltage so you can see. So 52 volts will give you 48. Let me increase it more. Reducing. So 50 will not give you 51.5, so 52 volts. So from 48 to 52 is 4 volts. So you must have 4 volts higher in the input for 50 volts in order to get 48 volts that we are getting. You see now 10 ampere. Now let's change the input voltage and output voltage so we can see it. We will read the input voltage in here. That's the input voltage, and output voltage will be shown in here. We will see also the current and the power on this screen. Currently it shows 30 volts, and if you're interested to purchase this, I will provide you the affiliated link below the video. It will help me if you purchase it through that link. Thank you. And let me set the output voltage from here. As you can see, input voltage is 109.8 or 110 volts. 30 volts. Let me change it to you see that's 99.9. So 100 volts is the output, and the current is set now to 17 ampere. Let's change it to 20. Now output is 100 volts. Now I've set the current to 1 ampere at 100 volts. Let's turn it on. The output current 10 ampere, 99.6. That's 1 kilowatt, 996. Now I have set the output voltage to 80 volts. If I press this, you will see I have set it to 80 volts, but we are reading 0.8, so 160 millivolts less. Let's go with 10 ampere. I've turned on this current sensing. I have voltage for sensing here. Make sure that voltage is not dropped on the line. So let's turn on with 10 amp. Here, now that is 10 ampere. This is not correct. This is now seems to be correct, 7.5. So the current is 7.45. And here is the efficiency. Let's set the voltage to 60 volts. So it is set to 60 volts. Let's go with 10 ampere. So that is 600 watts. Input current is 5.46 ampere. Now output is 36 volts. Let's go with 10 ampere. Input is 110 volts. Let's see the input current. Input current is 3.3 or 3.4 ampere. Now I have set the output voltage to 50 volts and the current is now set to maximum of 20 ampere. Let's turn it on. So the current is now being limited. Now output is 50 volts. Let me show you the input voltage. 50 volts and 10 ampere. .75. 4.8 is the current. Now I have set the output to 24 volts. Input is 110. Let's turn on with 10 ampere. Input current is 2.34 ampere. Now the output is set to 19 volts. Let's go with 10 ampere and turn it on. Let's measure the current. Input current. Input current is 1.89 ampere. And here now output voltage is 12 volts. Let's go with 10 ampere. Input is still 110 volts. Let's measure the input current. Input current is 1.22 ampere. Now output is 5 volts, 10 ampere. Input is 110 volts. Let me show you the input current. Input current is 540 milliampere, and output is 5 volts, 20 ampere. Let me show you the current. 1.16, 1.2 ampere. Now output is 12 volts, 20 ampere. Let me show you the input current. 2.55 ampere is the input current. Now 24 volts, 20 ampere. Input current is 4.6 ampere. And here now output is 36 volts. I have set the current to 20 ampere. Let me turn it on. Input voltage is still 110 volts. Let me measure the current. Input current is 6.8 ampere. Now output is 48 volts and 20 ampere. Input voltage is 109.3 volts. Let me show you the current. Input current is 9.4 ampere, and now input is about 91 volts. Output is set to 70 volts with 10 ampere. Let's turn it on. 10 ampere is the current at the moment. 698, that's 700 watts. Let me show you the input current. 7.93 ampere. Now with input of 91 volts, output is 50 volts, 10 ampere. Set it 0. Input current is 5.77 ampere. Now with the input 91, output is 36 volts, 10 ampere. Let's measure the current. Input current is 4.2 ampere. Here is the with 90 volts input and output 36 volts, you can get maximum of 15 ampere. You cannot get 20 ampere. As soon as I go 15 point something, the voltage is dropped. So this cannot handle it at that specific voltage. So only 15 ampere and it will work fine. Now output is 24 volts. Let me turn it on. 15 ampere is fine. Let's go 20 maximum. Oh, let's set it to 20. And set the current to 20. So as you can see, 20 doesn't work. Let's go a little less. No, 18 doesn't work. 14.8. 14 ampere. 14 ampere works, not more than that at this voltage with the input of 91. Now 19 volts. Some people like to charge or power the laptop. Let's go 19 volts, 14 ampere. It works fine. Let's go 20. 20 ampere doesn't work. So 15 ampere doesn't work. 14.6 works fine. Input current is here 3.4 ampere. Now I set the output to 12 volts. Let's go with 15 ampere, 14.6. So 15 ampere doesn't work. So (14 ampere, 12 volts we can get. Input current is 2 ampere or 2.1 ampere. Now output is 5 volts. Let's go with 14 ampere. 90 volts, 91.2 volts is the input. The output is 14 ampere, 5 volts. Let's go 20. 20 ampere doesn't work. 15. 15 ampere doesn't work. So 14 ampere we can get, and Input current is 1 ampere. Now I set input to 70 volts. Output is 50 volts, 14.8 ampere. Let's go 20 if it works to see. So 20 ampere is not working, but constant current has not turned on here, so the limit is not here. So 14 ampere works. Input current is 10.6 ampere. Here I set now input to 7. Now I have set the output to 36 volts. Let's go 14 ampere. Working. My electronic load is buzzing now. Input current is 7.71 ampere, and here is now output 24 volts, 14 ampere with input 70 volts. Let's see the input current is 5.19 ampere. Output is 19 volts. Let's go with 14 ampere. Let's see the input current, 4.18 ampere. Output is 12 volts, 14 ampere, 170 watts. Input current is 2.7 ampere. Output is 5 volts, 14 ampere. Input is 70 volts. Input current is 1.22 ampere, 3.3 volts. Let's go with 14 ampere. Let's check input current, 860 milliampere. Now I've set the input voltage to 50 volts. Now I've set the output to 36 volts. Input is 52, and I turned it on with 10 ampere. Let's go 20. So 20 ampere cannot be supplied with a 50 volts input, even though the output is 36 volts. Let's go with the lower current. No, so 15 ampere doesn't work. 14 ampere can work. So we can get 14 ampere and without even turning the constant current on. So the module cannot supply that amount of current, it just suppresses the voltage. So 14 ampere you can get at these voltages. Let me show you input current. Input current is 10 ampere. Now I set the output to 24 volts. Input is 52 volts. Let's turn on with 14 ampere. Let me show you input current. Input current is 6.8 ampere. Now with 52 volts input, output is 19 volts. And let's turn on with 14 ampere. And here is input current 5.5 ampere. Now with 52 volts, output is 12 volts at 14 ampere. Let's go 20 if we can get. So 20 ampere doesn't work as before. So 12 volts, 14 ampere. Let me show you input current. Input current is 3.6 ampere. And here output is 5 volts, 14 ampere with input 52.4 volts. Input current is 1.6 ampere. Now output is 3.3 volts, 14 ampere with input 52.4 volts. Input current is 1.1 or 1.2 ampere, 1.15 perhaps. Now I've set the input to 36 volts, output is 30 volts, 14 ampere. Input current is 12.29 ampere. Now output is 24 volts, 14 ampere current. Input current is 9.92 ampere. Now 19 ampere is the output with 36 volts, 14 ampere here. Input current is 8 ampere, 8.02. Now output is 12 volts. Output is now 12 volts and current is 14 ampere. Input current is 5.25 or 5.22 ampere. Now output is 5 volts, 14 ampere. Input current is 2.38 ampere. Now output is 3.3 volts, 14 ampere. Here is input current 1.7 ampere. Now input is 24 volts, output 19 volts, 14 ampere. Input current is 11.74 ampere. Output is 12 volts. Output is 12 volts, 14 ampere. Input current is 7.62 ampere. 5 volts, 14 ampere with input 24 volts. Input current is 3.45 ampere. Output is 5 volts, 14 ampere. Input current is 3.76 ampere, 90 watts. Now I set output to 3.3 volts, 14 ampere. Input current is 2.74 ampere at 24 volts. Now output is 12 volts, 14 ampere. Input is 19 volts. Here is the current and efficiency. Now output is 5 volts, 14 ampere with input 19 volts. Input current is 4.66 ampere. Now with input 19 volts, output is 3.3 volts, 14 ampere. Input current is 3.36 ampere. Now I set input voltage to 12 volts and here output is set to 9 volts. Let's go with 14 ampere, 9 volts. Input current is now 12.07 ampere. With input 12 volts, output 5 volts, 14 ampere. Input current is 7.23 ampere. Now input is 12 volts, output is 3.3 volts, 14 ampere. Input current is 5.16 ampere. I've set the input to 10 volts, that's the minimum. I've set the output to 5 volts, 14 ampere. Input current is 8.66 ampere. And here for MPPT, if I select this, I'm pressing the upper key multiple times until I see MPPT and it is on. I can turn it off from here, but let's keep it on and press this to exit. And I have set the voltage 13.7 and the current 3 amp. Now this is the input voltage from solar coming to that device, and here is the output current and voltage. So from solar we are getting 830 milliampere at 60 volts, and here the module, this module is supplying 13.39, 1.1 ampere. Because I have set the current to 3 ampere, this is not constant current, is not turned on, and the battery is getting that current. I can also show you in here 1.8778 or 76. Here, as you can see, it's simply clicking when the battery is not connected. Let me connect the battery. As soon as you connect the battery, it stops because MPPT is on. And let me show you the current. It shows 20 ampere. Because it shows, now it shows minus. If I put it properly, it shows positive because the cable is coming from here. Now 20 ampere is being charged. Now from my solar panel here we have 15.6 ampere that's coming from solar. 15.8 volt is being charged. Now let me show you how we can charge a lithium battery. We have to know the following. First, maximum charge voltage, we must know it. We must know also maximum charge current. And for lithium ion NCR 18650, the maximum charge voltage is 4.2 volts and people call it 3.7 volts. That's a nominal voltage. And charge current is maximum. You can go 1.65, but you can go lower, but that's the maximum. For lithium iron phosphate, when people call it 3.2 volts, it's actually the charge voltage is 3.65 volts. So we have to know this before we proceed with the charge. And the charge current, you can look at the data sheet, but that's the maximum. You can always go with the lower. The best practice for charging battery is to divide the capacity by 10. For example, if we have 3000 milliampere hour battery, 3000 divided by 10 is 300 milliampere. So that should be the charge current for that battery. And here, this is the example of 3-cell batteries. These are the nominal voltages for the battery. If we connect them in series, then we will use the top and bottom for the main load and charge. And because the charge voltage for the lithium ion battery is 4.2 volts, then 4.2 times 3 is 12.6 volts. That's what we set the voltage in our charger. And here is the example of 3 cells connected in series. This is the positive. The bottom is connected in here. The top is connected in here. So in series, we have one negative, one positive, where we can connect it to our load. If we have 3 cells, we connect them in series and multiply the voltage. For example, if we have 4 cells, and then here, one cell is 3.65 volts, and because we have 4 cells, multiply it by 4, and the charge voltage is 14.6 volts. Once you have the charge voltage and maximum current, then the module set the voltage at the maximum charge voltage, and for the current, set the constant current to the maximum current that you have for the battery. Now let's just charge the battery with this relay, so we can turn it off or disconnect it. You can connect the battery to the battery terminal or to the other terminal, but the difference is that this will just stop the voltage, but the current might get in back if the system is off. So always connect the battery to this terminal, so this relay will turn it off. Let me turn off the MPPT. Press and hold, go until you see MPPT, and then turn it off and exit. Now the current is 4 ampere, as you can see. It's, if I turned it off, you see the relay click. I've connected the oscilloscope in here, so we are reading the voltage, the ripples on oscilloscope. Now let's measure the output ripple. 10 ampere, 100 volts. And as you can see, the ripple is 608 millivolts. And this is the 10 ampere 80 volts ripples. Let's see. 484 millivolts. The ripples at 10 ampere 50 volts. Let me stop and run it. 444 millivolts. The ripple for 10 ampere 36 volts. The ripple is 480 millivolts. Here is the ripple for 10 ampere 24 volts. 400 millivolts. Here is the 5 volts 10 ampere ripple. And as you can see, it's 100 millivolts each. 1, 2, 3, 4. It's around 4.5, 450 millivolts. And here is the ripple for 10 ampere 5 volts. 600 millivolts, 620 millivolt is the ripple. This is the ripple for 48 volts 20 ampere, 808 millivolts is the ripple, and the frequency is 65.7 or 65.8 kilohertz. And here is the ripple 1, 2, 3, 4, 5, 500 millivolts. And here is the ripple 1, 2, 3, 4, 5, 6. So about 600 millivolts. I turned it on, and now the relay is on, and as you can see, the current, constant current, is set for 3 ampere. Here the input is 18 volts and the output is 13.4. Because we set the current to 3 ampere, now the current, the constant current, has kicked in and it is not allowing more than that. If you want to change the current, let's give, you see, also pay attention to the input current. I want to go with 10 amp. Now 10 ampere is being poured. And here right now the battery is being charged with 23 ampere, this 100 ampere hour battery. I just put it on maximum current that I could charge, and the fan is running. Let me show you the thermal image to see which spot is getting hot the most. So now this spot is 71 degrees Celsius. Let me bring my finger exactly in here. So that is this chip. This chip is now 71 degrees Celsius. Then the heatsink at this spot is very hot, 71 now. So let me zoom in. So you can see that 75 degrees Celsius at the moment, exactly at this spot where my finger is. Let me turn this by side. So right now it's totally by side. Let's see what is the hottest spot. 55 degrees around here. So that's the same thing. The heat is pumping. Let me turn it to the back. Let's see which spot is hot the most. And here 62 degrees in this area is 62 degrees. The white area is the hottest. Here this is the hottest spot. The core around 40 or 50 degrees, which is nothing. So still we can see this area a little hot, and this area is the winding, and then the relay is a little warm, 45 degrees, so nothing to worry about. For conclusion, that I would say that this is supplying up to 100 volts output when you input around 110 volts, and generally the input should be 4 volts minimum than the output. So if you want 40 volts at the output, you have to have 44 volts at the input. And also this cannot supply 20 ampere in all voltages. I have did the tests, so please watch the test and see at what voltages, but generally below 50 volts you can get 14 ampere consistently. From 3.3 volts up to 48 volts or something, you can get 14 ampere, but beyond 50 you will get 10 ampere up to 100 volts. MPPT option and direct charging is very useful because the relay will isolate your battery from your system, and you can connect directly to your solar and charge it by activating the MPPT option. Particular applications that needs noise, this is not a good option because it should be like 50 millivolts or 100 millivolts, but 400 millivolts is very high for a lot of applications. If you're interested to purchase this, I will provide you the affiliated link below the video. It will help me if you purchase it through that link. Thank you. In this video, we are going to do the review of this DPS 5020 50 volts, 20 ampere, constant current, constant voltage, with tons of protection, with mobile app and PC software. I'm going to explain the module, then under the magnifier we will look at the components of this module. After that I'm going to explain the settings, how to set this. After that I'm going to do the test with all standard voltages from 50 volts. I'm going to show you the efficiency. We are going to see also the ripple for major voltages under different load current. After that, I'm going to show you how to set up, how to download and install PC software. Then after that, I'm going to show you how to install the Android app, and then here